ImageDream, Image Prompt Multiview Diffusion for 3D Generation. We introduce ImageDream, an innovative image prompt multiview diffusion model for 3D object generation. ImageDream stands out for its ability to produce 3D models of higher quality compared to existing state-of-the-art image-conditioned methods. Our approach utilizes a canonical camera coordination for the objects in images, improving visual geometry accuracy. The model is designed with various levels of control at each block inside the diffusion model, based on the input image, where global control shapes the overall object layout and local control fine-tunes the image details. The effectiveness of ImageDream is demonstrated through extensive evaluations using a standard prompt list. For more information, visit our project page at project's website. FaceStudio, put your face everywhere in seconds. This study investigates identity-preserving image synthesis, an intriguing task in image generation that seeks to maintain a subject's identity while adding a personalized stylistic touch. Traditional methods such as textual inversion and dream booth have made strides in custom image creation, but they come with significant drawbacks. These include the need for extensive resources and time for fine-tuning, as well as the requirement for multiple reference images. To overcome these challenges, our research introduces a novel approach to identity-preserving synthesis with a particular focus on human images. Our model leverages a direct feed-forward mechanism, circumventing the need for intensive fine-tuning, thereby facilitating quick and efficient image generation. Central to our innovation is a hybrid guidance framework, which combines stylized images, facial images, and textual prompts to guide the image generation process. This unique combination enables our model to produce a variety of applications, such as artistic portraits and identity-blended images. Our experimental results, including both qualitative and quantitative evaluations, demonstrate the superiority of our method over existing baseline models and previous works, particularly in its remarkable efficiency and ability to preserve the subject's identity with high fidelity. XAdapter, adding universal compatibility of plugins for upgraded diffusion model. We introduce XAdapter, a universal upgrader to enable the pre-trained plug-and-play modules, for example ControlNet LoRa, to work directly with the upgraded text-to-image diffusion model, for example SDXL, without further retraining. We achieve this goal by training an additional network to control the frozen upgraded model with the new text-image data pairs. In detail, XAdapter keeps a frozen copy of the old model to preserve the connectors of different plugins. Additionally, XAdapter adds trainable mapping layers that bridge the decoders from models of different versions for feature remapping. The remapped features will be used as guidance for the upgraded model. To enhance the guidance ability of XAdapter, we employ a null text training strategy for the upgraded model. After training, we also introduce a two-stage denoising strategy to align the initial latents of XAdapter and the upgraded model. Thanks to our strategies, XAdapter demonstrates universal compatibility with various plugins and also enables plugins of different versions to work together, thereby expanding the functionalities of Diffusion community. To verify the effectiveness of the proposed method, we conduct extensive experiments, and the results show that XAdapter may facilitate wider application in the upgraded foundational diffusion model. LivePhoto, real image animation with text-guided motion control. Despite the recent progress in text-to-video generation, existing studies usually overlook the issue that only spatial contents, but not temporal motions in synthesized videos, are under the control of text. Towards such a challenge, this work presents a practical system named LivePhoto, which allows users to animate an image of their interest with text descriptions. We first establish a strong baseline that helps a well-learned text-to-image generator, that is, Stable Diffusion, take an image as a further input. We then equip the improved generator with a motion module for temporal modeling and propose a carefully designed training pipeline to better link texts and motions. in particular considering the facts that 1. Text can only describe motions roughly, for example, regardless of the moving speed, and 2. Text may include both content and motion descriptions. We introduce a motion intensity estimation module as well as a text reweighting module to reduce the ambiguity of text-to-motion mapping. Empirical evidence suggests that our approach is capable of well decoding motion-related textual instructions into videos, such as actions, camera movements, or even conjuring new contents from thin air, for example, pouring water into an empty glass. Interestingly, thanks to the proposed intensity learning mechanism, our system offers users an additional control signal, that is, the motion intensity, besides text for video customization. Describing differences in image sets with natural language. How do 2 sets of images differ? Discerning set-level differences is crucial for understanding model behaviors and analyzing data sets, yet manually sifting through thousands of images is impractical. To aid in this discovery process, we explore the task of automatically describing the differences between 2 sets of images, which we term set difference captioning. This task takes in image sets D_A and D_B and outputs a description that is more often true on D_A than D_B. We outline a 2-stage approach that first proposes candidate difference descriptions from image sets and then re-ranks the candidates by checking how well they can differentiate the 2 sets. We introduce VisDiff, which first captions the images and prompts a language model to propose candidate descriptions, then re-ranks these descriptions using CLIP. To evaluate VisDiff, we collect VisDiff Bench, a dataset with 187 paired image sets with ground truth difference descriptions. We apply VisDiff to various domains, such as comparing datasets, for example ImageNet versus ImageNet v2, comparing classification models, for example zero-shot clip versus supervised ResNet, summarizing model failure modes, supervised ResNet, characterizing differences between generative models, for example Stable Diffusion v1 and v2, and discovering what makes images memorable. Using VisDiff, we are able to find interesting and previously unknown differences in datasets and models, demonstrating its utility in revealing nuanced insights. Analyzing and improving the training dynamics of diffusion models. Diffusion models currently dominate the field of data-driven image synthesis with their unparalleled scaling to large datasets. In this paper, we identify and rectify several causes for uneven and ineffective training in the popular ADM diffusion model architecture, without altering its high-level structure. Observing uncontrolled magnitude changes and imbalances in both the network activations and weights over the course of training, we redesign the network layers to preserve activation, weight, and update magnitudes on expectation. We find that systematic application of this philosophy eliminates the observed drifts and imbalances, resulting in considerably better networks at equal computational complexity. Our modifications improve the previous record FID of 2.41 in ImageNet 512 synthesis to 1.81, achieved using fast deterministic sampling. As an independent contribution, we present a method for setting the exponential moving average, EMA parameters, post hoc, that is, after completing the training run. This allows precise tuning of EMA length without the cost of performing several training runs, and reveals its surprising interactions with network architecture, training time, and guidance. MVHumanNet, a large-scale dataset of multi-view daily dressing human captures. In this era, the success of large language models and text-to-image models can be attributed to the driving force of large-scale datasets. However, in the realm of 3D vision, while remarkable progress has been made with models trained on large-scale synthetic and real-captured object data like Objaverse and MVHumanNet, a similar level of progress has not been observed in the domain of human-centric tasks, partially due to the lack of a large-scale human dataset. Existing datasets of high-fidelity 3D human capture continue to be mid-sized due to the significant challenges in acquiring large-scale, high-quality 3D human data. To bridge this gap, we present MVHumanNet, a dataset that comprises multi-view human action sequences of 4,500 human identities. The primary focus of our work is on collecting human data that features a large number of diverse identities and everyday clothing, using a multi-view human capture system, which facilitates easily scalable data collection. Our dataset contains 9,000 daily outfits, 60,000 motion sequences, and 645 million frames with extensive annotations, including human masks, camera parameters, 2D and 3D key points, SMPL, SMPLX parameters, and corresponding textual descriptions. To explore the potential of MVHumanNet in various 2D and 3D visual tasks, we conducted pilot studies on view-consistent action recognition, human NeurF reconstruction, text-driven view-unconstrained human image generation, as well as 2D view-unconstrained human image and 3D avatar generation. Extensive experiments demonstrate the performance improvements and effective applications enabled by the scale provided by MVHumanNet. As the current largest-scale 3D human dataset, we hope that the release of MVHumanNet data with annotations will foster further innovations in the domain of 3D human-centric tasks at scale. Training chain of thought via latent-variable inference. Large language models, LLMs, solve problems more accurately and interpretably when instructed to work out the answer step by step using a chain of thought, COT prompt. One can also improve LLM's performance on a specific task by supervised fine-tuning, that is, by using gradient ascent on some tunable parameters to maximize the average log likelihood of correct answers from a labeled training set. Naively combining COT with supervised tuning requires supervision not just of the correct answers, but also of detailed rationales that lead to those answers. These rationales are expensive to produce by hand. Instead, we propose a fine-tuning strategy that tries to maximize the marginal log likelihood of generating a correct answer using COT prompting, approximately averaging over all possible rationales. The core challenge is sampling from the posterior over rationales, conditioned on the correct answer. We address it using a simple Markov chain Monte Carlo, MCMC, expectation maximization, EM algorithm, inspired by the self-taught reasoner, STAR, memoized wake sleep, Markovian score climbing, and persistent contrastive divergence. This algorithm also admits a novel control variate technique that drives the variance of our gradient estimates to zero as the model improves. Applying our technique to GSM-8K and the tasks in Big Bench Hard, we find that this MCMCEM fine-tuning technique typically improves the model's accuracy on held-out examples more than STAR or prompt tuning with or without COT. Fine-grained controllable video generation via object appearance and context. Text-to-video generation has shown promising results. However, by taking only natural languages as input, users often face difficulties in providing detailed information to precisely control the model's output. In this work, we propose fine-grained controllable video generation factor to achieve detailed control. Specifically, Factor aims to control objects' appearances and context, including their location and category in conjunction with the text prompt. To achieve detailed control, we propose a unified framework to jointly inject control signals into the existing text-to-video model. Our model consists of a joint encoder and adaptive cross-attention layers. By optimizing the encoder and the inserted layer, we adapt the model to generate videos that are aligned with both text prompts and fine-grained control. Compared to existing methods relying on dense control signals, such as edge maps, we provide a more intuitive and user-friendly interface to allow object-level fine-grained control. Our method achieves controllability of object appearances without fine-tuning, which reduces the per-subject optimization efforts for the users. Extensive experiments on standard benchmark datasets and user-provided inputs validate that our model obtains a 70% improvement in controllability metrics over competitive baselines. Orthogonal adaptation for modular customization of diffusion models. Customization techniques for text-to-image models have paved the way for a wide range of previously unattainable applications, enabling the generation of specific concepts across diverse contexts and styles. While existing methods facilitate high-fidelity customization for individual concepts or a limited predefined set of them, they fall short of achieving scalability, where a single model can seamlessly render countless concepts. In this paper, we address a new problem called modular customization, with the goal of efficiently merging customized models that were fine-tuned independently for individual concepts. This allows the merged model to jointly synthesize concepts in one image without compromising fidelity or incurring any additional computational costs. To address this problem, we introduce orthogonal adaptation, a method designed to encourage the customized models, which do not have access to each other during fine-tuning, to have orthogonal residual weights. This ensures that during inference time, the customized models can be summed with minimal interference. Our proposed method is both simple and versatile, applicable to nearly all optimizable weights in the model architecture. Through an extensive set of quantitative and qualitative evaluations, our method consistently outperforms relevant baselines in terms of efficiency and identity preservation, demonstrating a significant leap towards scalable customization of diffusion models. DragVideo, interactive drag-style video editing. To make the following text readable for a text-to-speech system and remove latex characters, please pre-process it accordingly. If there is a URL, replace it with the phrase project's website. In terms of mathematical notations, replace latex with something that can be read by a text-to-speech system without altering the meaning. Editing visual content on videos remains a formidable challenge with two main issues. 1. Direct and easy user control to produce. 2. Natural editing results without unsightly distortion and artifacts after changing shape, expression and layout. Inspired by Dragan, a recent image-based drag-style editing technique, we address above issues by proposing DragVideo, where a similar drag-style user interaction is adopted to edit video content while maintaining temporal consistency. Empowered by recent diffusion models, as in Diffusion, DragVideo contains the novel Drag-on-Video U-Net Dove editing method, which optimizes diffused video latents generated by Video U-Net to achieve the desired control. Specifically, we use sample-specific LoRa fine-tuning and mutual self-attention control to ensure faithful reconstruction of video from the Dove method. We also present a series of testing examples for drag-style video editing and conduct extensive experiments across a wide array of challenging editing tasks, such as motion editing, skeleton editing, etc., underscoring DragVideo's versatility and generality. Our codes, including the DragVideo web user interface, will be released. StableDreamer, taming noisy score distillation, sampling for text to 3D. In the realm of text-to-3D generation, utilizing 2D diffusion models through score distillation sampling, SDS, frequently leads to issues such as blurred appearances and multi-face geometry, primarily due to the intrinsically noisy nature of the SDS loss. Our analysis identifies the core of these challenges as the interaction among noise levels in the 2D diffusion process, the architecture of the diffusion network, and the 3D model representation. To overcome these limitations, we present StableDreamer, a methodology incorporating three advances. First, inspired by InstructNeRF2 NeRF, we formalize the equivalence of the SDS generative prior and a simple supervised L2 reconstruction loss. This finding provides a novel tool to debug SDS, which we use to show the impact of time annealing noise levels on reducing multi-face geometries. Second, our analysis shows that while image space diffusion contributes to geometric precision, latent space diffusion is crucial for vivid color rendition. Based on this observation, StableDreamer introduces a two-stage training strategy that effectively combines these aspects, resulting in high-fidelity 3D models. Third, we adopt an anisotropic 3D Gaussian representation, replacing neural radiance fields, NeRFs, to enhance the overall quality, reduce memory usage during training, and accelerate rendering speeds, and better capture semi-transparent objects. StableDreamer reduces multi-face geometries, generates fine details, and converges stably, generating fine-grained human motions using ChatGPT-Refined descriptions. Recently, significant progress has been made in text-based motion generation, enabling the generation of diverse and high-quality human motions that conform to textual descriptions. However, it remains challenging to generate fine-grained or stylized motions due to the lack of datasets annotated with detailed textual descriptions. By adopting a divide-and-conquer strategy, we propose a new framework named Fine-Grained Human Motion Diffusion Model, FGMDM, for human motion generation. Specifically, we first pass previous vague textual annotation into fine-grained description of different body parts by leveraging a large language model, GPT 3.5. We then use these fine-grained descriptions to guide a transformer-based diffusion model. FGMDM can generate fine-grained and stylized motions even outside of the distribution of the training data. Our experimental results demonstrate the superiority of FGMDM over previous methods, especially the strong generalization capability. We will release our fine-grained textual annotations for Human ML 3D and KIT. ReconFusion, 3D reconstruction with diffusion priors. 3D reconstruction methods such as neural radiance fields, NRFs, excel at rendering photorealistic novel views of complex scenes. However, recovering a high-quality NRF typically requires tens to hundreds of input images, resulting in a time-consuming capture process. We present ReconFusion to reconstruct real-world scenes using only a few photos. Our approach leverages a diffusion prior for novel view synthesis, trained on synthetic and multi-view datasets, which regularizes a NRF-based 3D reconstruction pipeline at novel camera poses beyond those captured by the set of input images. Our method synthesizes realistic geometry and texture in under-constrained regions while preserving the appearance of observed regions. We perform an extensive evaluation across various real-world datasets, including forward-facing and 360-degree scenes, demonstrating significant performance improvements over previous few-view NRF reconstruction approaches. Alchemist, parametric control of material properties with diffusion models. We propose a method to control material attributes of objects like roughness, metallic, albedo, and transparency in real images. Our method capitalizes on the generative prior of text-to-image models known for photorealism, employing a scalar value and instructions to alter low-level material properties. Addressing the lack of datasets with controlled material attributes, we generated an object-centric synthetic dataset with physically based materials. Fine-tuning a modified pre-trained text-to-image model on this synthetic dataset enables us to edit material properties in real-world images while preserving all other attributes. We show the potential application of our model to material-edited NRFs. GPT-4, a unified framework for point language understanding and generation. Multimodal large language models, MLLMs, have excelled in 2D image text comprehension and image generation. But their understanding of the 3D world is notably deficient, limiting progress in 3D language understanding and generation. To solve this problem, we introduced GPT-4, an innovative, groundbreaking point-language multimodal model designed specifically for unified 3D object understanding and generation within the MLLM framework. GPT-4 as a powerful 3D MLLM seamlessly can execute a variety of point text reference tasks, such as point cloud captioning and Q&A. Additionally, GPT-4 is equipped with advanced capabilities for controllable 3D generation. It can achieve high-quality results through a low-quality point text feature, maintaining the geometric shapes and colors. To support the expansive needs of 3D object text pairs, we developed Pyramid XL, a point language dataset annotation engine. It constructs a large-scale database over 1M objects of varied text granularity levels from the Objaverse XL dataset, essential for training GPT-4 Point. A comprehensive benchmark has been proposed to evaluate 3D point language understanding capabilities. In extensive evaluations, GPT-4 Point has demonstrated superior performance in understanding and generation. LLaVA-Grounding, grounded visual chat with large multimodal models. With the recent significant advancements in large multimodal models, LMMs, the importance of their grounding capability in visual chat is increasingly recognized. Despite recent efforts to enable LMMs to support grounding, their capabilities for grounding and chat are usually separate, and their chat performance drops dramatically when asked to ground. The problem is the lack of a data set for grounded visual chat, GVC. Existing grounding datasets only contain short captions. To address this issue, we have created GVC data that allows for the combination of grounding and chat capabilities. To better evaluate the GVC capabilities, we have introduced a benchmark called Grounding Bench. Additionally, we have proposed a model design that can support GVC and various types of visual prompts by connecting segmentation models with language models. Experimental results demonstrate that our model outperforms other LMMs on Grounding Bench. Furthermore, our model achieves competitive performance on classic grounding benchmarks like RefCoco plus JG and Flickr 30K entities. Our code will be released at the project's website. WhisBERT, multimodal text-audio language modeling on 100M words. Training on multiple modalities of input can augment the capabilities of a language model. Here, we ask whether such a training regime can improve the quality and efficiency of these systems as well. We focus on text-audio and introduce WhisBERT, which is inspired by the text-image approach of FLAVA. In accordance with Babylon guidelines, we pre-train WhisBERT on a dataset comprising only 100 million words plus their corresponding speech from the word-aligned version of the People's Speech dataset. To assess the impact of multimodality, we compare versions of the model that are trained on text only and on both audio and text simultaneously. We find that while WhisBERT is able to perform well on multimodal masked modeling and surpasses the Babylon baselines in most benchmark tasks, it struggles to optimize its complex objective and outperform its text-only WhisBERT baseline. Rank-without-GPT, building GPT-Independent Listwise Rerankers on open-source large language models. Listwise Rerankers based on large language models LLM are the zero-shot state-of-the-art. However, current works in this direction all depend on the GPT models, making it a single point of failure in scientific reproducibility. Moreover, it raises the concern that the current research findings only hold for GPT models, but not LLM in general. In this work, we lift this precondition and build for the first time effective listwise re-rankers without any form of dependency on GPT. Our passage retrieval experiments show that our best ListC re-ranker surpasses the listwise re-rankers based on GPT, 3.5 by 13%, and achieves 97% effectiveness of the ones built on GPT-4. Our results also show that the existing training datasets, which were expressly constructed for pointwise ranking, are insufficient for building such listwise re-rankers. Instead, high-quality listwise ranking data is required and crucial, calling for further work on building human-annotated listwise data resources. Axiomatic preference. Modeling for long-form question answering. The remarkable abilities of large language models, LLMs, like GPT-4, partially stem from post-training processes like reinforcement learning from human feedback, RLHF, involving human preferences encoded in a reward model. However, these reward models, RMs, often lack direct knowledge of why, or under what principles, the preferences annotations were made. In this study, we identify principles that guide RMs to better align with human preferences, and then develop an axiomatic framework to generate a rich variety of preference signals to uphold them. We use these axiomatic signals to train a model for scoring answers to long-form questions. Our approach yields a preference model with only about 220 M parameters that agrees with gold human-annotated preference labels more often than GPT-4. The contributions of this work include training a standalone preference model that can score human and LLM-generated answers on the same scale, developing an axiomatic framework for generating training data pairs tailored to certain principles, and showing that a small amount of axiomatic signals can help small models outperform GPT-4 in preference scoring. We release our model on the project's website.